Today I'll talk about differential equation. Here is the basic definition. A differential equation is an equation that contains derivatives of an unknown function. So here is the example, dy by dx is equal to 2x. So the dy dx is equal to, you can say fx is equal to 2x is a first order differential equation. Now order of a differential equation. The order of a differential equation is the highest derivative that appears in the equation. So here the example, d square y by dx square plus 3 dy by dx plus 2y is equal to e to the power x. So here d square y by dx square, so that has the highest derivative. That's why it is a second order differential equation. Now next is types of the differential equation. So linear versus non-linear differential equation. So linear, the dependent variable and its derivatives appear only to the first power and are not multiplied together. So here that y double dash plus 3y dash minus 2y is equal to e to the power x is linear, because here there is a no multiplication with that dependent variable. Now nonlinear equation, if the equation is not linear, so that is nonlinear. So here you can see that y dash is that multiplied 2 times, so that's why y double dash plus y dash square plus y is equal to x. That is nonlinear. Now next is homogeneous versus non-homogeneous. Homogeneous, so right side equals to 0. So whatever equation we have, so that is equal to right side is, if 0 is that homogeneous equation, and non-homogeneous right side is not 0, so that y double dash plus 3y dash plus 2y is equal to fx, means here function of x is nothing but e to the power x, so that's why it is called non-homogeneous. Now general form of the higher order linear equation, so we can write that higher order linear equation an dn d to the power n y dxn plus an minus 1 dn minus 1 y dxn minus 1 plus dot 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 plus a1 dy by dx plus a0 y is equal to fx. So here an minus 1 and a1 a0 are constant, so these are the constant, and fx is the function of x, and y is the unknown function we are trying to find out. So we are find out y is equal to something. Now for second order we can write that a2 d square y by dx square plus a1 dy by dx plus a0 y is equal to fx. So here a2, a1 and a0 are the coefficient for second order linear differential equation, and more commonly you can write y double dash plus px y dash plus q xy is equal to fx. So that we can write. Another way also we can write, this is a symbolic form, dny by dxn, so a1 plus a1 dn minus 1 y dxn minus 1 plus a2 dny dn n minus 2 y dxn n minus 2 plus any that is q. Now if I solve, so we'll get that y is equal to cf plus pi. Here cf is nothing but complementary function and pi is the that particular integral. So now here if I write in that operator notation, so dn, so this is dn plus a1 dn minus 1 a2 dn minus 2 plus dot 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 plus an y q, where d is d by dx and dn d to the power n by dxn. So now here auxiliary equation a or characteristic equation we can write that mn. So here that d is, you can write m to the power n a1 mn minus 1 a plus a2 mn minus 1 plus dot 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 plus an is equal to 0. From this characteristic equation we have to find out the root, and then we will get the complementary function or homogeneous equation. Now here, so earlier, so this is the general solution, or otherwise we can write like that way. So the solution of the non-homogeneous linear differential equation consists two parts. So one is yh, another is yp, or you can write complementary function plus particular integral. So here y is the general solution to the homogeneous equation, when fx is equal to 0, and y is the particular solution that satisfied the original equation. So now here is the step. Step 1, solve the homogeneous equation first, and then step 2, find a particular solution for the non-homogeneous term. And step 3, combine both solution to get the general solution, means y is equal to Cf plus Pi. Now here, that solving homogeneous second order equation. So for that equation, you can write that a y double dash, this is the general form, that second order, a y double dash plus b y dash plus c y is equal to 0. Now if I write that characteristic equation, so it will be like a r square, or a, last time I told you a m square plus bm plus c is equal to 0. So or here that characteristic equation is a r square plus br plus c is equal to 0. Now solve r using the quadratic formula. So r is equal to minus b plus minus root over b square minus 4ac by 2a. Now step 3, the form of the solution depend on the roots of the equation. So whatever roots we are getting, so based on that we will get the solution. So now here there will be 3 possible cases for the root. So case number 1, distinct real root. So if the characteristic equation has 2 distinct real roots r1 and r2, then yh, or homogeneous solution, or that complementary function will be yh is equal to c1 e to the power r1x plus c2 e to the power r2x. So here c1 and c2 are the arbitrary constant. And case 2, suppose a repeated real root. If the characteristic equation has a repeated real root, then yh will be c1 rx plus c2. So here x will be multiplied e to the power rx. Now if that root, if roots are complex conjugate, so that is alpha plus minus bi, then yh will be e to the power alpha x c1 cos beta x plus c2 sin beta x. So remember that alpha e to the power alpha x, and then beta will be that c1 cos beta x plus c2 sin beta x. Now here, that method of some undetermined coefficient when to use. This method works when fx is of the form. So fx is the suppose polynomial form, exponential form, fx is equal to the power ax, or sine cosine form, fx is equal to sine ax, or fx is equal to cos ax, or combination of the above. So what are the basic procedure? So guess the form of the particular solution based on fx. And step 2, substitute the guess into the original equation and solve the underdetermined coefficient, and this gives you that particular function. Okay, and combine will get that general solution. Now common form to try. So px is a0, a1x, a2 square x. We'll solve problem, then we'll understand better. E to the power ax, so a e to the power x, sin ax, cos x, so a sin x plus b cos x, and xn e to the power x, so a0 plus a1x, it is like that. And e to the power ax or sin bx means this function fx will be like that. So then e to the power ax, a plus sin bx plus b cos bx. So here is the important note: if any term in your trial solution is already in the homogeneous solution, you need to multiply by x, or x to the power k, where k is the number of times of the terms appear in yh. Now we are going to solve the problem, and so here example 1, when fx is equal to e to emx, or we are writing here y double dash plus 3y dash plus 2y is equal to e to the power 2x. So how we will solve this problem? So step number 1, solve the homogeneous equation. So that we need to solve that y double dash minus 3y dash plus 2y is equal to 0. Now first we have to form the characteristic equation. So r square minus 3r plus 2 is equal to 0 from, and if we do the factorization, we will get r minus 1 into r minus 2 is equal to 0. So here r is equal to 1 and r is equal to 2, that will be the two roots. Therefore the homogeneous solution will be yh is equal to c1 e to the power x plus c2 e to the power 2x. So here is the root 1 and that 2. So that we got that CF, complementary function. Now find the form of the particular solution. So here since fx is equal to e to the power 2x and e to the and e to the power 2x already appears in the, so here, so 1 is e to the power 2x and that 2x is already here. Okay, so then so already appeared in the homogeneous solution, so we need to multiply by that x. So yp will be a x e to the power 2x. Okay, then we need to find out the a. So what we have to do is that first, this is our yp, then first we have to do the derivatives. So y dash p is equal to a e to the power 2x plus 2x e to the power 2x, so that will be a e to the power 2x plus a 2a x e to the power 2x. Now again we have to do that derivative, that yp double dash will be a 2 e to the power 2x plus 2 e to the power 2x plus 4x e to the power 2x. So that will give 4a e to the power 2x plus 4a x e to the power 2x. Now if I plug that original solution, this is the original solution, so we have this, and then if I reorganize, we'll get, finally we'll get this, and from that we'll get both sides, we have to check that coefficient, and from that we'll get the value of the coefficient. So here, so this side, left hand side, right hand side, so a e to the power 2x, so here e to the power 2x, here also 2x, so we have to match that coefficient. So here that a1 and this right hand side is the 1, so a will be 1, so yp will be x e to the power 2x. So earlier we got that yh, and now yp is equal to x e to the power 2x. So general solution will be y is equal to yh plus yp, that will be c1 e to the power x plus c2 e to the power 2x plus x e to the power 2x. Another problem, so when fx is equal to sine mx, so now y double dash plus y is equal to sine x. So now solve the homogeneous equation. So y double dash plus y is equal to 0. Now characteristic equation is r square plus 1 is equal to 0. So r is equal to plus minus I. Now here that imaginary solution root is actually coming. So therefore homogeneous solution is yh is nothing but c1 cos x plus c2 sin x. That is the CF. Now here that find the form of the particular solution. So since fx is equal to sin x, so both sin x and cos x already appear in the homogeneous solution, so we need to multiply by x. So yp will be ax cos x plus bx sin x. So now we need to find out a and b. So for that, first we have to derivative that yp. So y dash p is equal to a cos x minus ax sin x plus b sin x plus bx cos x. So then again we have to do the double derivative. So yp double dash is equal to minus a sin x minus a sin x minus ax cos x plus b cos x plus b cos x minus bx sin x. So now from here we will get that yp double dash. So that will be minus 2a sin x minus ax cos x plus 2b cos x minus bx sin x. Now we have to plug that the original equation. This is my original equation. After plugging, we will get this. So from here, so left hand and right hand side, we have to match the coefficient, compare the coefficient. So comparing, we'll get minus 2a is equal to 1, so a is equal to half, and 2b is equal to 0, so b is equal to 0. So from that, y will be minus half into cos x. So finally, we will get the general solution. So y is equal to yh plus yp. So that is c1 cos x plus c2 sin x minus half x cos x. So another example I can take, that is a practice problem. Y double dash plus 4y is equal to sin 2x. So again characteristic equation we will get r square plus 4 is equal to 0. So our roots will be that plus minus 2y. So homogeneous solution will get c1 cos 2x plus c2 sin 2x. So now here, since sin 2x is already in yh, so multiplied by x, so x a cos 2x plus b 2 sin x. Now we have to do the double derivative, single and double derivative. So y dash b is equal to a cos 2x b sin 2x and minus 2a x sin 2x plus 2bx cos 2x. Let's just do that that derivative for this. Okay, now second derivative we have to do that, and after second derivative we have to substitute in that equation and simplify. So that will give minus 4a sin 2x plus 4b cos 2x is equal to sin 2x. Now comparing the coefficient, minus 4a is equal to 1 and a will be minus 1 by 4 and 4b is equal to 0, so b will be 0. So solution will be yp is minus 1 by 4 cos 2x, and general solution, so that is y is nothing but CF plus pi, so that will give C1 cos 2x plus C2 sin 2x minus 1 by 4 cos 2x. So now solving third and higher order equation. So higher order linear differential equation we can write as a y to the power n plus a n minus 1 y n minus 1 plus dot 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 plus a1 y dash plus a0 y is equal to fx. So that the approach is similar to the second order equation. Solve the homogeneous equation and then find a particular solution and add them together. So here characteristic equation we can write that r to the power n a n minus 1 r n minus 1 plus dot 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 a plus a1 r plus a0 is equal to 0. So here n is the order of the equation. We need n linearly independent solution to form YH. So now here one question example is given. So y triple dash minus y is equal to x square. So now here characteristic equation will be that r cube minus 1. So from that we'll get that r minus 1 into r square plus r plus 1. So here one real root and two conjugate root we will get. So r1 is equal to 1, r2 is equal to minus 1 plus root 3 I by 2, r3 is equal to minus 1 minus root 3 by 1 by 2. So here homogeneous solution will be c1 e to the power x plus c2 e minus 1 plus root 3 I by 2, c3 to the power minus 1 minus root 3 I by 2x. So using Euler formula we can write that c1 e to the power x plus e to the power minus x by 2 c2 cos root 3 by 2x plus c3 sin root 3 by 2x. So now we have to find out the particular solution. So here fx is equal to x square, so we use the, and that is a polynomial, we will use that yp is equal to x square plus bx plus c, and then we have to find out y dash p, that is 2x plus b, and y dash double dash p is equal to 2a and y triple dash is equal to 0. After that we have to plug in the original equation. So that is the original equation, we have to plug that, and after that if I compare the both side, left hand side, so we'll get a1 is equal to minus 1 and other things will be 0. So yp is nothing but minus x square. Now so this is particular integral, and already we know that cf, so we can yh plus yp. So if we plug that complete solution will be c1 e to the power x plus e minus x by 2 into c2 cos root 3 by 2x plus c3 sin root 3 by 2x and bracket close minus x square. So that's it. Thank you.